This is lesson 1.2, Rational Numbers in Decimal Form, part 1. Just a reminder that all the questions we're doing in this chapter, you should be able to do them without a calculator because we need to know how to do these skills by hand. So if you need to use the calculator sometimes when doing your homework, that's okay, but know that we will not have calculators on the test for this chapter 1. So we start with the difference between terminating decimals and repeating decimals. Terminating decimals are decimal numbers that end. So example 4.56, and I listed a couple others. Whereas repeating decimals, those decimals go on forever in a repeating pattern. So 1 over 3 is 0.333333, and this goes on forever. I wrote in green here, the notation that we use to write repeating decimals looks like this. We just put a straight line over the pattern that's getting repeated instead of writing it out forever or using dot, dot, dots. Another example would be 7.14141414. It doesn't have to be the same number, just as long as it's the same repeated pattern. And again, we put that solid line over the pattern that's getting repeated. So a reminder that an irrational number, pi, is 3.14159, etc. And it continues in a pattern that is not repeating. So we wouldn't be able to write this out with a line because this pattern does not repeat when we write out pi. So this part 1 is about adding and subtracting rational numbers in decimal form. I've written out the steps of how to add them. So the easiest way is to use a number line, whether you write it out or just think about it in your head. And you start at the first number that's being added in the question. So 3.6, for example, plus negative 1.2. You draw out your number line and you write your 3.6 right over there. If you're adding a positive number, then you go to the right. And if you're adding a negative number, then you go to the left. So for this example, we're adding a negative number. So we're going to move left on the number line, and we're going to move left by 1.2. I think it's easiest to go in chunks of 1. So we're at 3.6. If we go to the left by 1, then we're now at 2.6, because that's an easy calculation to do. We've only moved 1, but we need to move 1.2. So that remaining 0.2 has to be moved to the left from your 2.6. So we've got 2.6 minus 0.2. That leaves us with 2.4 as our answer. This example is if we had added 1.2 instead of subtracted it. So we would just move the other way on the number line. We'd be going right instead of left, but we follow the same method. First, we add 1 to get us to 4.6, and then we add the remaining 0.2 to get our final answer of 4.8. Subtracting rational numbers in decimal form is very similar, except the direction you move on the number line is switched. So if you subtract a positive, you go left on the number line. If you subtract a negative, you go right. And that's because the negatives are going to cancel each other out. So in this example here, we're subtracting a positive. Well, really this 4.3 is just, that's a negative because the subtraction sign is in front of it. So it's like adding a negative is the same as subtracting a positive. So we started our number line, we started at 5.7, and we have to move to the left 4.3. So first we move by our whole number 4, because that's an easy calculation to do. 5.7 minus 4 gets us at 1.7. Then we have to subtract the remaining 0.3 to get us at our final answer of 1.4. This example here is the same thing, except we've switched the sign. So since we're subtracting a negative, these two actually become a positive, so we're going to go right on the number line. And then it's the same idea. We start at 5.7, we're going to add 4, then we add a remaining 0.3, and we get our final answer of exactly 10.0. Something to be careful about is when you're crossing 0 on the number line. So all the examples we've looked at so far stay on one side of the number line, or sorry, of 0 on the number line. And it gets tricky when you cross it. So this example, negative 1.28 plus 3, that's going to end up being a positive number. So as you can see on this number line, we start about here and we end over here. So we've crossed 0. When we go through these steps, so just like normal, we're going to be going to the right because we're adding a positive. So we start by adding 1. Negative 1.28 plus 1 gives us negative 0.28. That's easy so far. But this one that I've starred, this operation is a little bit more complicated. Negative 0.28 plus 1 is now going over 0 on that number line. And so this gives us 0.72. A common mistake people might make is say negative 0.28 plus 1 equals positive 0.28. But that's not true. That is not true. So you have to do it this way. And I wrote the calculation here to maybe help you out. We know that 0.72 plus 0.28 is going to give us our full 1.00. So this calculation is true there. And then once we're over a number line, it's the same easy thing. We're adding 1 because we're adding a total of 3. So 0.72 plus 1 gives us 1.72. Lastly, estimating is a really important skill to have, and I've written out the steps of how we can estimate when we're adding or subtracting decimal rational numbers. So first, you're going to round to the nearest integer, and then just add or subtract like normal. So example, if we had this equation here, 8.9 plus 2.3, if you weren't quite sure how to add them, if we just round both of these numbers, so round 8.9 up to 9, and round 2.3 down to 2, and then we approximate this, 9 plus 2, that's an easy calculation, it gives us 11. And the actual answer is 11.2. So it's surprisingly quite close, and it's way easier to do. So if you're ever unsure of yourself and you don't have your calculator, then try estimating. And it's also a great way to check